So hi, welcome everybody. This is number 7. Oh, wow, not doing the right way. So this is IoT Deep Dive number 7. Welcome one, welcome all. Can I get a show of hands for whose first time this is? Cool, we got a lot of repeats, awesome. Okay, can I get a show of hands for people who do not know how to use mbed? Awesome. So a little bit of forewarning, we're going to be doing topics on IoT. We're going to be using an online tool suite called mbed. This is because I work for them and they pay for the pizza and beer. So outside of that, I will try and minimize my my adverts. It's actually a really cool set of online tools that lets you cross-compile for a whole bunch of ARM, Cortex, and chips. So you'll see people in the room having a bunch of different little boards. I brought about 50 of one type of board because I got them donated. So you'll see a lot of people with one type, but you'll see like this guy here has got a Nordic, that guy back there has got a Seed-Arch BLE board. I think someone had one of the other Kinetis lines in here, a different Freescale board. There's a couple like right there. And what's miraculous about this is all these chips are built by different vendors and they can all run the exact same code. Because the online tool chain is like, oh yeah, don't worry about it, we'll take care of it. So today we're going to be focusing on APIs. So in case you haven't done so already, please grab the prep. You need a board, a cable, another board, an adapter board, and another cable. Your entire setup should look like this when you're done. So I've got a Freescale blue board, a little ribbon cable to attach to the ESP breakout purple board, and then I've got another tiny blue wireless board. So make sure you've got all these parts. If you don't, they're all right up here for you to grab. We brought extra ESP chips. So did anyone bring their own ESP chip? Did you guys know? Okay, who of the guys who brought their own ESP chip, who did not update the firmware? Who did? Okay, take your chip, hand it to that guy back there. Sam, raise your hand. So give your chip to Sam and grab one of the ones out of the box. We're just going to swap you because there's only 5 of you and I don't want to take a half hour to show you how to upgrade your firmware.
Yeah, I've got.
You brought your own?
No, yeah, I brought mine. Did not open it.
So give that one to the guy in the back and grab one out of the box. So if you want to a purple breakout, you need one of these. They're also in the box. Okay, cool. So everyone's got their chips. If you want your chip back at the end of the class, go talk to the guy you just handed it to and he'll trade you back. Anywho, if you haven't downloaded the slides already for the class, please go ahead and download the slides. There's going to be a decent amount of copy and paste because we're going to be doing some command line stuff. So it'll behoove you to just have the terminal commands where you can copy them. If you'd like to, while I'm talking, you can also grab an IFTTT, that's 3 T's, account. We're going to be using that to demonstrate APIs. So when we get to the API section, you can either watch and learn or you can participate. I highly encourage participation. For that, you'll need one of their accounts because their API, their account. That's all there is to it. Yeah?
Yellow and white, do you know which one's TX and RX?
Actually, in a couple slides, I will show you.
RX is yellow. Ah, okay, cool, thanks.
So today we're going to briefly cover a review of last class and the class before it. We're going to talk about sockets, TCP, UDP, give a brief review of HTTP, talk about what an API is, what REST is, and then we'll have a challenge at the end. Based on the feedback that I've been doing over the last couple of months, I've had people asking for more hands-on time. So I structured this class different. Instead of doing a show and then a do and a show and a do and a show and a do, I'm going to do a bunch of show, a really quick do, and then a much longer do. Get your minds out of the gutter. It's not do-do. It's do time, like working on stuff. So that means we're going to have about 35 minutes to an hour at the end where we're just going to hack on stuff. Sound cool? Awesome. Okay, so Wi-Fi, ESP 8266-01, that's this little blue chip, all of y'all should have one. This is how you wire it up. So everyone go ahead and wire it up to your K64. This is why I said to grab the sides too, so that as I move on, you can still wire it up. Unlike last time, I do have everything in the right place, so we won't have those power issues again. So if you want to do the firmware update on your own, I heard someone ask questions about that. There are instructions here on how to do it. They're in the slides. I'm not going to cover this today in class because it's like a 30-minute process. So I'm just going to leave it up to you to follow the really awesome instructions we wrote. Yeah.
Did it change since the last class?
It has not. There are, however, new people who weren't here for the last class, so I'm mentioning it again. Right, and then there's instructions on checking your connectivity. Awesome time, great job. So, sockets, TCP and UDP. The socket abstraction layer is a thing that lets you have modular software. It sits between layers 4 and 5 of the OSI network interface. Essentially, it's what allows you to have software that doesn't care about what your hardware is. It's the magic of being able to write a piece of PHP code and not caring if it connects to the internet via Wi-Fi, Ethernet, or GSM. Because somewhere down the stack, someone's going, oh yeah, no, socket calls. I'll do TCP, UDP, open, close, send, receive, and then the hardware implements the rest of it. So sockets is this nice little abstraction layer that happens right here. And it's incredibly important for embedded systems. TCP and UDP, they're the basis of every protocol that exists on the internet. If someone claims they don't use TCP or UDP, they're either lying or they've created their own ridiculous scheme that no one else can use. So HTTP review. HTTP is based on TCP. It has a guaranteed connection because of that, because TCP guarantees a connected state, UDP doesn't. You send requests and you receive responses. There's 3 fields in each packet. You send a request type, some headers, and an optional payload. You receive back a status line. It's like 404 not found or 200 OK. You receive back some headers and you receive back a payload. Usually in that payload, you get your web page. So if you make like a GET request, you'll get back an HTML page in the payload, and that'll have like your header and your body and all that markup. So that was a lot of information that I just covered from about 2.5 months. Are there any questions before I move on? No, really?
Does this thing need to be connected to Wi-Fi?
It does. We'll get to that in a minute.
All right.
That's actually like slide 24, I think. Yeah. So APIs. Really, they're just a fancy way of saying a well-defined language for computers to talk to computers. Because computers process ones and zeros, they don't understand maybes very well. You have to spell everything out for them in absolute terms. An API is a very pedantic way of nitpicking your sentences so that a computer can understand you. It's also a way to have a computer talk to a computer so you don't have to worry about certain things. You can just hit a single button and you'll talk APIs to everyone else and they'll take care of it for you. So it's really handy for automating things, and it's absolutely critical to the web because it allows one server here to talk to a server over there and you never have to worry about it. In general, they have these key value pairs that they exchange. There's a whole bunch of different types of APIs. With almost all of them, you'll find a key value pair of some sort. Usually it'll be like username is John, address is 100 Main Street, phone number is his phone number. You can think of these as database entries with associated data pairs. You can think of them as key value pairs from Python, as dictionaries from JSON, or sorry, I got that back mixed up. Key value pairs from JSON, dictionaries from Python, however you want to do it. Every API has got key value pairing. There's also the issue of authentication in almost every API that exists. If there isn't authentication, that means they don't care who accesses it. While those do happen occasionally, they're kind of rare. So you'll see, you've probably heard of OAuth, basic auth, or a token. If anyone here has done old school networks, remember the ring tokens? You'd have to get a token to validate that you were a valid user on the network. Same basic idea. There's some sort of authentication to prove that you are a unique user who is a valid user. It's also how they associate your data to you as a user. Some things like tokens are just a hash of random numbers that they're like, hey, when you sign up for the service, here's your number, don't tell anyone about it. There's other ones like, I forget if it's basic auth or OAuth, that actually have a challenge response pairing, where you challenge in, hand one thing, they hand the thing back, you have to then do some magic to it and hand it back again, and then they let you in. So various levels of authenticating, but everything has it. now that we talked about the overarching generalities of all APIs that exist, we're now going to focus down on REST. There are other types of APIs that exist, but REST makes up, it was like 87 point something percentile of the internet's APIs that exist, makes up over 95% of the public facing APIs. So odds are if you're going to use an API with your embedded system, it's going to be a REST API. So that's what we're going to focus on for the rest of the day. REST stands for representational state transfer. As you might have guessed, that means it's stateless, which means each REST interaction is its own little contained unit. Some servers that claim to be REST won't do this. They'll have things carry over, and you get into this whole super nerdy debate about, is it RESTful? It looks RESTful, but it's not actually RESTful. So I'm just going to generalize, and instead of using the little e, I'm going to use the capital E, which usually denotes that it accesses via HTTP, that it accesses along URL lines, and that it's fairly straightforward to understand in most common languages. Savvy? So there are four methods of HTTP that REST relies on. This was done to leverage existing infrastructure. The whole idea with REST was people are saying, so I'm talking to this guy over here, but we've got slightly different tweaked implementations of how things work. Things are really kind of going buggy on us. We need to create a new standard for communicating. We need an API, but we don't want to have everyone add a new protocol to talk in that API. And so what they do is they say, hey, everyone has HTTP, everyone can access the internet, let's use that. So they took a subsection of HTTP and said, okay, this is going to do this, this is going to do this, this is going to do this, and this is going to do this. Everyone good? Cool, moving along. Those four things were get, post, delete, and put. What you'll see is there are suggested guidelines and best practice guidelines, but how everyone implements those are actually different depending on their API. So one person can say, oh, the delete method, if you send me that, then I'm going to delete something out of my database. Whereas someone else will say, the delete method, that just clears your cache for the last 15 minutes. So you have to really read the spec for the API that you're going to be using to determine which one does what thing. In general, get is used to pull data out of the database. Post is used to push things into the API. Delete and put tend to vary widely between APIs. Again, if you search REST API best practices, there's a whole lot of hipsters with really big glasses who have a lot of opinions on it. So I go forth and Google. The other thing. REST is not technically limited to using JSON only for its payload, for its key value pairing, but again, over 90% of them do. The old school way to do it was using XML. The problem with XML is it's really bulky and heavyweight, and it's not very forgiving, whereas JSON can be relatively forgiving depending on how you define it. And almost every language has got a JSON library built into it now, whereas not so many use XML anymore, or if they do have those libraries, they're super out of date. So by and large, REST means you'll have JSON as your payload. It's not required, it's just what you'll see most of the time. So that's what I'm going to talk about. Other thing to note is that REST, because it uses existing infrastructure, every implementation is usually pretty darn light and pretty darn fast. That is why, by and large, it has proliferated as much as it has across Ruby, Perl, C has a REST implementation, go figure. Any scripting language you find will have it. Any non-scripting language you find will have it. Some things that you didn't think would have it will have it. REST is everywhere. Everyone has a client for it because it's so lightweight and quick and easy to implement. That's why it's become the de facto standard for the internet today. So we're going to talk about how get and post work in REST APIs, because those are the two things that are used the most. Get, you transfer data using the query string. So you've got like a URL, and then at the end of it, you've got a slash question mark, key equals value, ampersand, key equals value, ampersand, key equals value, ad infinitum. The way that you know that the query string is starting is the first letter is a question mark, and then everything after that is the query string. Different key value pairs are separated in the query string by using the ampersand. That's how you transfer it to get line. Get is sent through the web browser's address bar, and it's public for everybody to see on the internet. So if you're going to go to a website, you can pass in optional data. Like if you go to google.com and then you search something, you'll see the search bar change from google.com to google.com/question mark. Blah, 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 blah. All that stuff after it are key value pairs that it's transferring back and forth to your browser. And it kind of uses it as a temporary cache. It kind of uses it as a way to interact with your cookies, and it uses it for a whole bunch of other things that I really don't understand. But it is a way to trivially transfer data back and forth. That said, there is a limit on the size of, Brian, what's the limit on get size? Is it like
2,000
2048?
characters or something like that.
Yeah, it's like 2,000-ish characters is about as long as it can get. Post, however, does not have that limitation. Post does not send data in the query bar. It sends it as a packet of data after it's made its initial query to the server. So Get will query the server, go, hey, I'm here, and here's all my stuff at the same time. Whereas Post will go, hey, I'm here, and I'm about to send you this thing of this length. You ready? Okay, here you go. And it'll send it along after the initial chirp message. Post is what you wind up using for any sort of data you want secured. By default, HTTP is not secured, so you'll want to use like HTTPS to secure it and then post it, that kind of thing. You can also encrypt your post data. Encrypting your get data is much harder because the question mark, the ampersands, and a couple other things, you have to code out special characters that are not A through Z or 0 through 9. So it makes encrypting a lot harder because you have to encrypt it and then translate it, hope it gets across okay, translate it back, and then decrypt it. Whereas with Post, you just encrypt it and send it, and the other guy goes, hey, cool, checksum, got it, decrypt it. So if you want to do any sensitive user data, put it in do a Post message, not a Get message. These are some examples of an API. I'm going to minimize that because the screen is clipping. So if this then that is the API that we're going to be referencing for the rest of the class, so all the examples are going to be based off of it. This Get and this Post are the exact same request. They do the exact same thing. They just have slightly different formatting. So if you look, the Get has got HTTP, maker.iftd.com, a whole bunch of stuff. And then at the end, it adds the question mark and then the query string. And it's passing key value 1, data v1, key value 2, data v2, key value 3, data v3. Post is then doing the same thing, but it's putting it into a JSON payload where it encodes it as JSON strings instead of as the query string formatting. Any questions on the difference here?
So Get, you're asking for data from a server. Post, you're putting data on the server, right?
So that's the weird thing. Get is traditionally used, if I didn't pass any parameters, I'd just be saying, hey, I'm going to this address. However you interpret that is up to you, but I want the thing at this address. So if I didn't have those query parameters on there, or if I do have them on there, it's asking for the same resource. It just has the ability that in the query parameter, it can pass extra metadata that it wants. That metadata field, although it is bad practice to use it to enter things into your database or into your backend, because anyone can see it, anyone can intercept it, anyone can modify it, it is done more often than I'd like. So usually the Get string is what is modified on the response. It redirects you to a page that has a bunch of Get stuff in it, so that when you hit it again, it brings that along with it.
Another big thing is the gets can be cached. There's a lot of caching semantics that posts don't have, so that's a concern.
So you can experience speedups for small amounts of data. Again, there is the 2,000 character limit, and it is totally unsecure. So things like Google Maps will send your location data there. Because if you're using Google Maps, you're looking for a location. So it'll log your longitude and your latitude in there, plus wherever you were previously. So if you hit the back button, you can be like, oh yeah, there you go. But you'll do see how these are the exact same thing. They're sending the same key value pairs. It's just formatted as a query string or as a JSON packet. One's Get, one's Post. Cool. They do the exact same thing when they hit the server. So this is the layout of the Get packet. I'm going to drill this in again and again because it's really important to understand how it works. Because on high-level systems, you don't have to care, but we're doing embedded systems. So when something goes wrong, you actually have to go look inside the packet and go, okay, am I missing a new line character? Am I missing a space here? Did I miss a period there? It really does matter. So this would be an example of a socket connection where TCP would say, hey, I'm going to connect to the server located at this IP at that address. Then once it has that connection open, it's going to send this packet. This packet is a Get string with a, God, I'm blanking on the word.
Path?
Yes. Thank you. So it says Get, it gives it the path into the server that it wants. It's saying it's using HTTP 1.1, and then it specifies the host that it's connecting to. And then this right here is a new line. There's not a new line here, just the font did that on its own. So one line, and then a new line with nothing on it. So it's CRLF, nothing after it. That is a sentinel for the end of packet. Savvy? That is a GET packet. When you go to a web address, that's all you're sending. By the way, this host maker.iftt.com, if you do a DNS name resolution to it, it resolves to this address. So when you type into your search bar, go to google.com, it in the background will hit a DNS server, go, hey, what's the IP for google.com? DNS server will go, oh, it's 8.8.8.8.8. Hand it back, and then it goes, okay, cool. Opening a socket to 8.8.8.8 on port 80. I'm going to send it the path string. I'm going to then say I'm connecting to host google.com. Cool. That's its entire request field. It then gets a response packet back that says something like status 200 OK, host google.com, here's your payload. It hands it back to the Google search page that you asked for. Savvy? This is the identical thing for a post packet. Post packets are a little bit more complicated because you have to specify the length of the data you're sending and the type of the data you're sending before you send the data. If you send stuff without telling it what you're sending it, it'll sit there and go, no, and shut you down and be like, I'm done, I'm walking away. So what we do is we say post, so we specify the request type. We specify the exact same path, and then we specify the HTTP type. We then have 3 lines, host maker.iftt.com, which again corresponds to the IP. We have the content length, which is the length of the payload. I went and I measured it out. It's like 46 characters, I want to say. So I replaced this bracket to bracket with a 46. I would then say the content type is application/JSON, because this is all encoded as JSON data. And then down here, I would have a new line character, a CRLF with nothing on it. Then there's this line with all the data, and then there's a CRLF again with nothing on it, and that's the sentinel character for end of packet.
Do you have to have the content dash type?
Yes, for post you absolutely do. If you don't, 9 times out of 10, the server will go, you sketchy, and shut you down. Occasionally, they'll have a backfall where they'll go, oh, you did post and then you sent garbage. I'm going to assume you wanted the thing here, so I'm just going to give you the thing there. Because really, up until the point where you specify this, the difference between post and get is trivial. You just obviously won't get the data across that you were trying to send. Any other questions? Good. So, go ahead and sign up for an ifttt.com account. We are going to use their API to send text messages or trigger notifications on your phone or upload stuff to Google Docs. It's going to be real fun. Yeah. So while y'all are doing that, I'm going to talk about one other thing real quick. IFTT allows you to trigger actions. So, for example, I send a trigger to ifttt.com and I say, hey, here's the event name that I've registered with you, which is, in my case is hello world. So I'll say /trigger/event name hello world /with/key. When you sign up for the service, you get a secure token, which is your secret key. You copy paste that in place of secret key and you send it in. When I get this address, the backend server, instead of saying, here's the web page at that address, it goes, oh, hey, this is an API call, because REST talks through those URLs. What you've done is you said /trigger, effectively saying, hey, to the API called trigger, I want to pass it an event name with a key, this thing. What are you going to do about it? The backend server then goes, oh, hey, cool, I see your secret key. That means you're this user. Cool, I see you're asking for this event name. Yeah, you registered. That's legit. Okay, the thing paired with this action, the value to that key in the database is, in my case, send me a text. And so it then goes, cool, sending me a text sent, and then it hands back as the response to this GET page, yep, we did that. So in this case, you're not asking for a web page. You're sending in a command to an API. And that's what REST does. It uses URLs that are traditionally used for resources. It uses them to do API calls on things. So I could just have easily had a thing that said /database/add user, and then in the key value pair for the post data said name, John, phone number, 1234, address 100 Main Street. And as long as it validated my secret key was correct, it would say, oh, hey, cool, we're going to add a new user. His name's John, his address is 100 Main Street, and his phone number is 1234. Cool, added, done, sends the accept message back down. I see a lot of dazed looks.
No maker channel?
We're doing the maker channel.
Oh, do you have to create one?
Yes. So sign up for an IFTT account, go to the maker channel and add the channel to your account.
See it.
I cannot see the channel.
Cool, I'll walk you through it real quick. So we're gonna add the maker channel. We're going to create a recipe. And yeah, so I'm gonna show you how to do that right now.
So what channels are interested? There's no maker.
Oh, there is.
I did a search for.
So, if I go to iftt.com,
Did you
right,
see maker?
and then I go to channels,
Later.
go to channels,
Here there's no maker.
and then go to search channels, and search for maker,
Maker.
right there. It's right there.
And you have to finish this setup. It is.
You have to put something else in there.
No, there's no maker there. This screen. It's up because it's
Blocking.
right after you register.
And see,
Yeah, so right after you register, it says select channels that interest you.
scroll
And
down
then
to the top. Yeah, just click on this.
That was like the maker.
Okay. That's weird. It didn't do that for me earlier. Yeah, there you go. You just go back to IoT.com.
Is that your chip or you borrowed one?
Alternatively, you can go to iftt.com/maker. That'll do the same thing. So you want to get to the maker channel. Once you're on the maker channel, you're going to hit add to channel or add channel. I already did, so I'm already there.
it's good. Connect.
It's called connect. So you want to hit connect. The next thing you're going to see is a thing right here called how to trigger events. So we're going to click on how to trigger events. It's going to give you a bunch of really cool stuff. The thing you care about is this bit of text right at the very top, which is your secret key. So you're going to want to be able to come back to this because you're going to need it later on to trigger things. Just waiting for everyone to get there. Good. Okay, awesome sauce. So the next thing we're going to do is create a recipe. So to create a recipe, we're going to go to the top. I'm going to go back. Ooh. Oh, did I really do that? I did do that. There we go. So we're going to go to My Recipes. You're going to click on it. You're going to click on Create a Recipe. You're going to click on that. Then we're going to click on this, because we're going to select this trigger. I'm going to select this. I like to do SMS because everyone here has a phone on them, and that's about all that you have to do is tell them your phone number, they send you a PIN, you send it back, and you're good. Alternatively, you can do notifications. Like I did one for, I spelled that wrong. So yeah, there's one right, where's Android notification? Android device or Android SMS. So I did that. There's also one for iOS notifications. You can do all kinds of cool stuff. But you're going to want to select, oh, sorry, this is the this. My bad. So type maker. Sorry, this is the first thing. The first thing is maker. So type maker and select maker channel. So you select maker channel. You can only choose one thing, so you're going to click on this. So you're going to click on it. You're going to give it a name. I call mine Hello World because I'm really lame like that. I'm going to hit Create Trigger. Now I'm going to select the action that trigger is going to cause. So at this point, we've done two things. We've registered the maker channel and we've set up a trigger on that channel. So you now have an event name called Hello World, and we have the secret key that we got when we first registered. So we have both an event and a token we can use to access it. We're going to click on that. Now we can choose all kinds of fun stuff like Android notifications or iOS notifications. You just want it to pop up like at the top of your phone to like swipe down and dismiss kind of thing, you can do that. If you want to do text messages, you can do text messages instead. Just pick one. If you don't want to install another app on your phone, choose SMS. Because if you choose the iOS notifications or Android notifications, you'll have to download the app and then register it with your account. So just saying. So I'm going to do SMS. At this point, because I've already registered my phone number, it's not asking me. You'll have to fill out a little thing saying, here's my number. They'll send you a PIN number. You'll write the PIN number back in real quick. Let me know when y'all are done. Who's not done? Not done. I gotta wait a couple more minutes.
With this maker channel, we can only send just 3 values at a time.
Correct. Yeah, you're limited to 3 values because that's their API. They could just as easily say 7 or 500, but they said 3. And it's free, so we don't really get to complain too much. So the maker channel that we've registered gives us the ability to send a couple things. Back on that page from earlier, I can go back to my channel and click down here on the triggers, and the triggers would tell me exactly what I'm able to send as triggers. It tells me I've got, enlarge that, it tells me I've got event name, value 1, value 2, value 3, and occurred at. These are all things that come in with the API request. The event name,
How did you get to that?
I scrolled down on the channel and clicked here.
Oh.
This is from way back earlier. I'm just showing you a quick reference. So if you wanted to check what the API has, that's the API reference. Anyhow, back on the recipe page. Is everyone good to make a recipe to finish the recipe? So as you noticed, it does have 3 values. So I'm going to say event name occurred at. I'm going to click this little thing right here. Select an ingredient and put the occurred at field, which will give me a timestamp. Add ingredient with v1 equals add the ingredient for value 1. v2 equals add the ingredient for value 2. v3 equals add the ingredient for value 3. So now that I've done that, I now have event name, occurred at, value 1, value 2, value 3. So I'm pulling every piece of information out of this API and sending myself a text message with it in it.
How do we get back to our key?
I'll show you how to do that in a second. For the moment, it's automatically doing it in the background, but we'll have to go find it manually when we do the embedded code and the command line code here in about 2
I'm not
minutes.
seeing how you edit anything.
Click inside the box.
Yeah, when I clicked mine and I
Nothing
tried to do that, I hit that little thing, it
Yes.
just put me in here.
All right, so you're here. And click here. Oh, maybe script blockers turned on.
I don't know.
Okay, well, in that case, go ahead and just do the curly brackets. Because it's essentially auto-inserting curly brackets for you. it's looking like most people are either there or partially there. You can come back later on and edit what it sends you as a text message. So if you don't have all the values in there, don't worry about it. You can come back and fix it in a bit here. So I'm going to say create action. It registers it on the server and it says, okay, give it a name. I just give it the default name. Creates it. And awesome. There we go. For the people who ask where your secret key is, if you go to, actually just go to iftt.com/maker. I'll take you back to the channel. It's the easiest way to navigate it, honestly. Your secret key is right here. If you click on it, it takes you to this page, and the page tells you everything you need to know. So, is everybody on this page? If everyone could get on this page, we're going to make it really easy here. We are going to take this first line. We're going to copy it. So I'm going to do Control-C, open up a new tab, and paste it in. And I'm going to go replace event with my event name. So I'm going to put in
Our event name should have been small now.
Yes, it should have been, which is why mine was Hello World. So I'll show you here.
I think yours was hello world without the D.
I've got like 7 things registered. I'm cheating a little bit. So I hit enter. And sure enough, I just got a notification right here from if this then that. It just popped up on my screen. If I refresh the page, did I refresh? I refresh. Refresh doesn't do it. I gotta hit it. Yeah, there we go. Got a second and a third notification. So what I just did was using a GET request, I loaded the page. Because remember, if you go to a URL, it loads the effective address as a GET request. So by visiting that web page in my browser, I was triggering the trigger via GET request. So if everyone can do that and just verify that their API is working correctly, we can then move on to the next step.
No SMS.
You didn't? Everyone complete the recipes and the challenge that came with the recipe to register your phone number?
They never did that.
You never?
They never asked me about my phone number.
Well, then how are you not getting an SMS?
Yeah, that's why I was.
Except, okay, with no SMS came.
Let's check. Let's go to iftt.com/my
Yeah, it's
recipes.
No, not there.
You're
supposed to paste your secret
email
key.
Phone number, is that your correct phone number?
Yeah.
Oh,
Yes.
Oh, don't put the. Oh, here. Don't put the
Keep the
plus.
plus.
Yeah, no plus.
Does it have to be hello world for it to work?
No, it can be any name. The name has to be alphanumeric. So A through Z, 0 through 9. Nothing else. No dashes, no spaces, no underlines, no specialty character shenanigans.
came now.
It can?
Plus was extra.
There you go. So his is working. Whose API is not working?
Oh, to what?
You're not working?
Yeah, mine says required in the event, but I
Same here.
never got,
So that is your recipe. Oh, the B, I guess it's.
Go to
Oh, up to there?
Where'd my recipes?
Where'd that come from?
So you never created the recipe.
Oh, I watched it.
Create recipe.
So why did our secret key have that? It's just garbage.
Well, yeah, I can see the URL, but that means that you set up a path. It doesn't mean you registered and then triggered with that.
What made you get rid of that?
Okay, then you got
Oh.
Go to maker. So type in maker.
So when I trigger my recipes, it goes.
So,
Yeah.
yeah, I'm just wondering why I put in that extra garbage on the key.
So here.
Search for SMS.
Yeah.
Yeah, so like when I first put in this, so it goes,
Create recipes.
So So you need to actually, you need to fill in there.
Oh, I see. So I think I just deleted the event, but I need to get rid of the percent 70 on each side.
It's whatever event you wire to the trigger for. I think you can actually not bind it to any event if you want to, but.
Cool. Okay, now that worked when we did it scattered. Yeah, that's weird. When I pasted this key, it had a generic
That's the
event.
recipe title.
Yeah.
Yes, but it's not actually.
Because I didn't give it a make the page. I'm speechless.
Yeah, I did. I already got it too.
Oh, beautiful.
Wow.
Oh.
Is that when we work on this stuff?
Do what?
Like, could you log this to say, like, oh yeah, I'm gonna keep my kids off of Facebook, so every time they trigger their homepage, it notifies you, or is that a whole other deal?
It depends on if there's an event, if there's an if to do that.
Oh, where it's actually logging
Facebook is on here.
their login status, I guess. You basically be querying the Facebook page to see if they're logged in as online.
I don't know if you can do that or not. Looks like he's got it pulled up there, and if you connect it, you can see what all the different like triggers are.
Oh. Because I mean, you could maybe even do it with your page and just see if they're logged in as active.
I'm sure you can do that with a graph API, but
Online or offline.
Somebody checks that gives that out, they're not gonna. What's the other?
Oh, there'll be like offline mode or something.
Occurred at.
Yeah.
Sorry, 1, 2, 3, and occurred at.
Yeah.
It's very easy to get around that.
Does my event name need to be inside those brackets?
Well then.
No, you get rid of the brackets entirely.
It's like, what do you use this for? This particular facet here is awesome, but what cool things should you do with it?
Well, you got devices here, you can have sensors triggered.
yeah, if you have a water leak, you can set a water sensor to send you a text. That there's
Okay,
water.
awesome. So now that everyone's got a recipe that's registered, we're going to move on to the next step.
So activate the website.
If you've got OS X or Linux, you should be able to follow along. If you've got Mac, if you've got Windows, unless you've installed curl already, you won't have curl. So just bear with me for a second. What I'm doing is I'm walking you through all the steps of validation for any API you'll use in the wild. First, you'll try and hit it using your web browser just to verify that things work. Then you'll try using curl to see if you can manipulate things and send especially data packets to trigger things. And then you'll use it on your embedded system once you've got the API all worked out. So the next step. Oh, damn, I even had a nice slide on this. Forgot about that. So we click on how to trigger events, gives you the page. Click on that, it gives you this page with the entire thing. So we've triggered it using the get in the browser. Now try sending yourself a couple values through the browser. Try adding question mark value 1, all undercase, equals something. Don't try to do more than one. Just do question mark value 1 equals something. Again, alphanumeric, A through Z, 0 through 9. And see if your phone comes up and says, hey, event occurred, event name with value 1 equals, and it gives you the thing you just typed in. Beautiful.
I did a notification and it's not triggering a notification on my phone.
Did you install the app on your phone?
Logged in.
Also, what's the secret key?
Verify you actually have the recipe.
Secret key is your personal secret key, so it's that.
Turned on.
I don't know if it's an update now.
I guess that's just like a parentheses.
Or just put a,
Oh,
Copy this.
Yeah, copy that.
question mark.
You gotta replace.
Change it to S times.
In the end, slash.
Should be working.
That's good.
I have no idea what's going on.
Yeah, for some reason it doesn't show up in my list of your notifications that are usually show up.
It didn't show up.
You gotta find this first.
Maybe because it's in data.
All right, I'll do SMS.
Yeah, SMS will surely work. So, who's been able to send values in their get string?
So just like any number.
Awesome!
28.
Okay, 7. I'm going to go on to the next bit then, just to keep us moving. So now we're going to use curl commands. Curl, as I said, is a command line tool that is the command god of all things internet. No matter what you want to do, curl can probably do it if you're trying to test anything anywhere on the internet. It has the most complete HTTP stack in existence. It supports a couple of the HTTP stack variants that shouldn't exist but still do exist. It knows HTTP better than the book does because it's the tool that was used to build the internet. That said, much like all the tools that were used to build things, it can be ridiculously complex and pedantic and unforgiving. And so I've equipped you with the very basic commands you need to get things running. If you were ever looking to build your own API or fully test someone else's API, Google and curl are your friends. Google especially when you're using curl. It's been around since the mid-'80s at the very latest. So there is a Google question or a forum post somewhere where someone has done what you will want to do using curl. So I'm going to copy this, or not. This is directly copied from the other page. So all I did was I took this curl command right here on the bottom. Control C, I'm going to bring my curl terminal over so you can see it. I'm going to say insert. So it says curl-x post. I'm going to, instead of having event, I'm going to say hello world. I'm going to hit enter. And it gives me back the same message that we got on the website, which says, congratulations, you fired the hello world event. And sure enough, my phone right here now has a new notification on it. If I do this one more time.
What about the curly braces that you left still there, which didn't affect it?
Let's try getting rid of them, shall we? It works as well. Apparently that's something in your API. Yep, now I get 2 notifications. One piece of advice, you can add a -v command that will give you a lot more information. -v. That just told me everything about the connection that it is setting up. And I mean everything. So you can see it says a bunch of stuff about SSL and HTTPS because I did HTTPS because that's what they have by default. HTTP would also work, in which case all the SSL stuff goes away. It then tells you, oh, here's the really cool part. Right here, these little brackets are. It says what the actual packet is that it's sending across. And then down here, when it gets these little curly brackets coming back, it actually tells you what the packet was that it got back. So you can sit here and verify that it says post/address HTTP 1.1, user agent curl, because like I said, curl's spiffy and has its own user agent. It then says host maker.iftt.com, because it figured that out. And then it just adds a little thing saying, I accept anything you want to hand me. And that's the GET request that we just fired. It's kind of awesome.
What was the flag? Was it
Sorry,
T or
oops.
capital V?
Lowercase v. I know it'll give you a lot of really verbose information. I'm just telling you about the verbosity flag because it can be handy, much more handy than the server saying, nope, that didn't work. Okay, why didn't it work? So you can now look at the packet and see what's missing. For example, when I first started making this IFTT library, I was trying to just send GET requests at an IP. Turns out IFTT.com requires this host header. If I didn't put in host:/maker.iftt.com, it would ignore my request entirely. Because I don't know what you're doing. This then told me by experimenting with other APIs that it uses subdomains to route its API traffic. So instead of having in the URL /API/maker API, it just assumes that anything that's coming to maker.iftt.com is to the maker API and routes it accordingly. The rest. So going back, there's then another trigger down here that just adds the query string to the end of the URL I'm sending. So that's another way to query and then send values along with it. There's a curl command for doing post. This first one is the exact same thing as the get one. It just replaces the word get with post. And then the second one here, this is actually where it gets interesting. The second command sends data along with it, which means it has to then specify the header length and the header type. So it says, hey, I'm going to add a header. The header is content type application JSON. It then says, here's my data, hands it the data, and then it hands it the URL. So we've got two extra flags, the -H for the header and the -D for the data that it's sending. Notice there is no header for saying content length. That's because curl, being as spiffy as it is, goes, oh, you're doing application JSON? Cool, by spec that requires me to send the length of whatever data you send, and it automatically sends that along with it as well. So if I wanted to double check that, which I did, I would copy paste this command, add the -v to the front of it, and watch the data going out and go, oh, he added a content length thing. Cool, I should do that in my API too. So I did. Okay, now that we have made it work with both the web browser to just check basic viability, we have learned about curl commands and how to use them to a certain extent. We are now going to do the embedded code. This, by the way, is the way you would naturally develop and check an API out in the wild. So if you want to go develop your own API, say hook up to Twitter, because they're actually finally starting to come out of their shell about that. You probably have to use OAuth or basic auth in addition to what I just showed you, but otherwise it'd be the exact same thing. You'd have a token, you'd have an event name, the path that you'd follow would be different because their API would be different. So you just go download their spec and be like, twitter.com/API/user ID/secret key/post/message. And there you go. You just posted a message to your Twitter, et cetera, et cetera, et cetera. The way you would do it is you'd first make it work with the web browser by trying to paste it in there. Then you'd go to the command line with curl and say, well, I wonder if I said, instead of user, if I said group, would that do anything? Oh, cool, they've got this subsection over here in their API that says groups can do this and users can do this. And oh, there's a thing that lets me specify where I am in the world and check into Foursquare at the same time. Type that all into the curl command and see if it works. Curl is the quickest way to check the API and to try and hit it and to just rapidly prototype with it. And then once I've got it all figured out and I know exactly what I want to send and exactly what it has to look like, I then take it to the embedded space and turn it into embedded systems code. And I just really pedantically copy paste with all the lines and everything else. So go grab the embed code. We're going to compile it for the boards on your desk, load it, and you are going to have it trigger the notification that you just sent. I know, right? And we're still way ahead of time. Cheers. I know, right? That comes in. So for example, if you go to that web page, it will take you and up there, up there. Where does it take you?
It's to the embed page.
Hang on, I know exactly where it takes you. If anyone's interested, by the way, this is what mbed.org looks like when you can spell. There's a little thing up here called components. I'm going to the components section. I scroll down, there's a thing called online services. I go into it, and sure enough, there's the IFTT API. So I'll click on that, and I get to this page, which if you follow the link from the Google Docs slides, will take you to the exact same place. So this is where we are. For those of you who remember how to do this, you click on import your program, you import it, change your event, change the secret key. You'll see them very clearly. It says, hey, change me, I'm the event, and hey, change me, I'm the secret key. 1 second, I swear I'm coming. And then the wireless, you have to set up the wireless because we're using the ESP. I've got a little wireless access point running over there. It is called demo SSID, so this right here. And then the password is nothing. So the way that you would represent that is you would have 2 quote marks with a space and 2 quote marks. You just put a space in there.
One space.
1 space. Because it is not encrypted, so there's no password.
I'm working out of space.
Sweet, that means the nice little lady right there in the back has upgraded the library since last time. Good job.
So all we got changed is the SSID, the password, enter our event and our secret.
So here's the main file. See if I can blow this up a little bit. So here's the main file. Make that a little bit bigger. Make it bigger. Oh, come on. There we go. So up here, for the wireless password, change it to demo SSID. Change the next field to just a blank space or, nothing. It's just going to ignore it because it's unencrypted, so there's no password. You will need to change the first field, which if you look at the comments at the end, the first field is your event name, the second field is your secret key. So you'll need to copy and paste in your event name or just type it in. So yours is what, DX? Mine was Hello World. Someone had a really long complicated one back in the back corner. So write it in and then copy paste your secret key in from that page from earlier that I told you you need again.
Does this whole thing support WPA, things like that, or is it?
Yeah, actually it does.
It just auto detects, I guess, basically, that's all.
Pretty much. The API for it, so he's asking what the interface is for wireless. The ESP has got this great little stack on chip. And so I just go, hey, I want you to connect to this network name, this thing, and here's the password. And if it happens to be an open access point that's connected to, it automatically goes, I don't need a password. Likewise for WPA2 and all that, it figures out what it's connecting to, and if it needs anything, it just does it. It's quite handy.
What about the socket?
Oh, no, don't change anything else.
Leave that, okay.
Don't change anything else. If you look at the code itself, you'll notice that down here, it's going to send you it's going to send 3 triggers. The first trigger is going to send 3 values, and it's going to say testing is awesome, testing, and then data. The second one is going to sending get data, and the third one is going to sending post data, or post things. If you look further at it, you can tell that by default, it sends data in post. By not default, you can then further specify whether you want it to send it via get message or via post message. It's a really simple API. If you want to open up the library, which by the way is located right here, I encourage you to. Here's the iftt.c and .h. It's about 60 lines of code in total. And all I did was open up a socket, send across those lines of text that I showed you earlier, get/path http 1.1, host maker.iftt.com, new line, et cetera, et cetera. So I taught you enough today that you could rebuild this API if you wanted to. So if you want to dig into it, by all means. Once you've swapped out your event name and the secret key, go ahead and compile it, load it to your board, and run it. Those of you who do remember how, your terminal will print out, hey, I got an IP address and shenanigans is happening. Then you'll later get whatever notification you set up. Those of you who don't remember, there's 3 nice people in the back. Call them towards you and they will show you how to use the terminal. Oh, one thing to remember, when you load the code onto the board, press the reset button and that makes the code run. It does not run automatically.
But it's in debug mode. Because it's in debug mode.
No, it's just reloaded into memory and you need to reset it.
It supports everything. It's crazy.
So this thing also, as well as when the serial
Why do you have Y1 there?
So what?
Why do you have the Y1 there?
Oh, because once I've sent the 3 messages, I don't want to do anything else.
Why don't you just finish? Why don't you just finish? Why don't you let it?
Because depending on what microcontroller you use, exiting out of the main will then restart your chip.
Okay.
So, unlike certain PICs and Arduinos that hang after you exit main because it's not really main, on ARM chips, that's actually a main function. If you exit that, who knows what your architecture will do? Because the underlying architecture then kicks in, and unless you've got an RTOS running in the background, it'll do whatever the hell it wants. It'll randomly start running random points in memory. So, never ever exit main.
Never thought I was.
Yeah, do it. See what happens. Oh, right. I guess I should show you what this looks like when it runs successfully. So guys, really quick, if you run this code successfully, it is going to look like this.
Well, you think if one got through, then someone would get so.
You can just screen it, but I don't really want the problem. There is a program called screen SCR.
So this is the output you'll get on your terminal if it runs successfully.
I know that after you reboot it, I know how to screen, so I just close the terminal and. For some reason, the value is always.